All right, guys, this week you are going to be looking at describing different parts of functions on a graph. Okay, so there's a couple different notes, things that we're going to go through about some different ways that you can describe a graph. And then we're going to look at an example of interpreting it with a situation. All right, so first thing we're going to look at is a word that you have probably heard before. Hopefully, at this point, you've heard before linear. So, for those of you who don't remember what linear means, that just means that it's a straight line. Okay, so linear, think line, think a straight line. So, a linear graph can literally be any graph that is composed of just a straight line. So, this would be an example of a linear graph, just a straight line across. That's not very straight, but you kind of get the idea. Just a straight line across a graph would be considered linear. I'll just keep drawing more just so you can kind of get an idea. Something going straight up and down would be a linear graph. And then, like the opposite of this line going downwards, that's also linear. So, linear graphs are what we see most of the time right now. It's just any graph that is linear, it will have a constant rate of change or slope, if you heard that word. All right. So, the next one we're going to be looking at, this is linear. The next thing we're looking at is nonlinear. So, you've probably seen the prefix non in English class. Okay, that just means it's not linear. So non-linear graphs are literally anything that is not a straight line. Okay, so a really typical one you're going to see a lot, and you'll see it a lot when you get into Algebra 1, is a graph that looks like this. Kind of looks like a U or a smiley face. This is non-linear because it is not a straight line. It is a curve. We can see that it kind of goes downwards, and then it curves around and goes back up. Okay. There's a couple other examples of nonlinear graphs. Remember, it's literally anything that's not straight. Here's another one that you'll see when you get into Algebra 1. And we can see that even though this one is increasing the whole time, it curves a bit in the middle. Okay. So it doesn't have a constant rate of change. It's not changing by the same amount every single time. All right. And then there is one more type of nonlinear graph that you guys will be seeing. And some of you may have seen these before, and we'll be getting into them in a minute, but sometimes graphs can also, oopsies, sometimes graphs can also have different parts to them. So say a graph is straight for a little bit, but then it like curves off at the end. Okay, so part of it is straight, but part of it's not. So this is a nonlinear graph, right? So linear graphs, straight lines, nonlinear graphs have not straight lines. Okay, linear, line, nonlinear, not a line. All right, so now that we know our different types of graphs, we're going to look at trying to describe them. So when you're doing this lesson in iReady, you're going to be focusing on not only thinking about is this line, is this graph linear or nonlinear, but you're also going to be looking at whether that graph is increasing, decreasing, what's the graph doing? Okay, so like I said before, you're gonna have sometimes graphs are gonna have like multiple parts to them, like we see here. Okay, sometimes it's just one graph that has multiple different parts to it, but it's still just one continuous curve or line. And when you talk about whether a graph's increasing or decreasing, you have to take the whole graph into account and all of its parts. All right, so if we go back, let's go back for a second back to our linear graphs. Okay. If we look at just this blue line, so I'll get rid of, let me see if I can get rid of this red line. Yeah. So if we look at just the blue line, this blue line is obviously increasing. Okay. We know that from left to right, this line is going upwards, which means the line is increasing. The graph is increasing. Okay. The whole thing is increasing. If we look at this blue line over here, it's not increasing or decreasing. It's staying the same. Okay. It's keeping a constant y value. All right. Now, the difference between this and when we look at our graphs that have multiple parts to them is that we can see parts of the graph are increasing, but parts are decreasing. Okay, so we have to look at how we can describe that. So with this graph specifically, we can see that for this little interval, let me see if I can highlight it maybe. We can see that for this little interval, the graph is increasing. So you're going to see in iReady that it's going to describe it in terms of x values. There's a bunch of ways to describe how things increase or decrease, but this one specifically is increasing from an x value of 0 to an x value of, let's see, 0, 1, 2, 3, to an x value of 3. So that's when it's increasing. Okay. I'm just kind of shorthand that so you can see it a little bit better. So that's when the graph is increasing, all right? But if we look at this other part of the graph, and I'll highlight this in a different color, for this part of the graph, it's decreasing. So for this second little interval from when x equals 3 until x equals 6, that's 6 right there, the graph is decreasing. Okay, so there's two different parts to it, and you're gonna have to look at specific x intervals for what that graph is doing. Now we can say the same thing for nonlinear graphs. So this graph over here now, you can probably already tell that this graph, well, it's decreasing, and here it's increasing. But do you have to think about the fact that it's curved? And the answer is no. It really doesn't matter how quickly a graph is decreasing or how quickly it's increasing. It doesn't matter if it doesn't have a constant rate. If it's continuously going downward from left to right, it is decreasing. So this graph, we would say that it is decreasing until the x value of -2. And then after -2, the graph starts increasing again. Okay, so you kind of have to look at where the graph evens out. It doesn't actually hit a flat line down here, but it kind of hits that turnaround point and then starts going the other way. All right, so we have a decreasing section and we have an increasing section. All right, so we've looked at linear, nonlinear, increasing, decreasing, and now we're going to look at how these different things affect a graph of like a word problem. So how we can use these different things to interpret what's going on inside of a situation. So we're going to look at this graph here. We've got a little situation going on. I'll read through it for us. Okay, so it says that this graph is showing a trip on a bike trail. The trail has markers every half of a kilometer, showing the distance from the beginning of the trail. So we can see that this graph is made up of a whole bunch of different parts. Okay, and all those parts are straight lines, which means that for each part, we're riding at a constant rate. Okay, but let's think about what all these parts mean. So first, we want to know, when is the bike rider going the fastest? Okay, so think about on a graph, if something's going fast, it's going to have a very, very high rate of change, or a very, very high high slope, sorry, a larger slope. Okay, which means the graph is going to increase very rapidly. It's going to have a steeper line. Okay, so let's look at this graph. What parts look the steepest? I know it's not anything in this center section because those are like very not steep. Okay, I can tell that this section here is less steep than the one up here. So it's really just between these two. Okay, and then you just want to look at your blocks, but we know that the section of the graph, and yours is going to be a little bit more obvious and iReady, we can tell that the section of the graph that is moving the fastest is just going to have the steepest slope, and that is in fact right here. So question A is in green. That is the steepest part of the graph. So that is when the bike rider is moving the fastest. And you can look at the opposite thing to think about, when are they going the slowest. All right. So in this case, we can see which part has the lowest slope. And for right now, we're going to ignore the parts where it just doesn't have a slope, or has a slope of 0, sorry, because they're not actually moving slowly there. They're just not moving at all. And there's actually a question down here that asks about, when did the rider stop? So we'll look at that separately. So when are they moving the slowest? I can see that this part right here has a very not steep slope. It has the least steep slope on this graph, least steep rate of change. So we know that that part of the graph is where the bike rider is going the slowest. Okay. So next thing we want to, and actually let's cover E while we're at it because we already kind of covered it. At what time did the rider stop? So we can see that the rider stopped for this interval and for this interval right here, okay? So they're actually just staying in place because their distance isn't changing even though time's changing. So it asks what time, all right? So you would just kind of look at, well, they stopped right here, zero point 0.8 hours. We don't know when they started, but zero point 0.8 hours into it, they stopped for a little bit. And again at 2.2, they stopped for a little bit, okay? Um, so really just recognizing where on the graph, what parts align to the story. And then the last two questions, so let's look at C. During what times was the rider going away from the beginning of the trail? So we know that on our axis over here, this is distance from the beginning, okay? So if they're moving away from their beginning, it means that their point on the graph is going to get further and further and further, which means their distance is going to increase. So let me get rid of some of these markings so we can see better what's going on. All right. So we're just looking at when are they moving away? We're literally just looking for when is that graph getting further from the beginning point. And that is going to be every section in which the graph is increasing. Okay. So because their distance is increasing. All right. So it's increasing, I'm going to say generally from here to here. Now, do they stop in little parts here and there? Yes, they do. But generally, they are moving away from the trail from the beginning or from their start from the beginning time until about 222 or 224. That is when they're moving away. Okay. And then during what times was the rider going back towards the beginning of the trail? And that's going to be everything we haven't marked because that's the part where they are going back to start. They've reached the top or they've reached the place that they were trying to get and now they're trying to get back to the car. Looks like they're going really fast, so maybe they're going down a hill or it started raining, so they're trying to get out of there. But this is the part where they're returning back to the beginning because it is a downward slope, so their distance from the beginning is decreasing. Right? So in iReady, you're going to have to look at comparing multiple different graphs. My best piece of advice for you guys is to try to use the little pens in iReady to mark it up a little bit like we did here. Really just focusing on where is it increasing, where is it decreasing. Make sure you look at the labels on your graph because those are going to tell you a lot. All right. Just be careful when you're reading the questions. Make sure you understand what it's asking. And as always, if you have any questions, please make sure you either reach out through email or you can pop on Zoom. And that's all I got for you guys. See ya.